Today we're going to practice converting linear equations into slope-intercept form. And we'll also look at one great feature of the slope-intercept form that we don't see with the other forms of linear equations. So let's get started. Here we have the equation 2x minus 3y equal to negative 16. And we're asked to rewrite this equation into slope-intercept form. Now currently this is in standard form. And with standard form, we have ax plus by equal to c. So this equation shows the relationship of these variables x and y, this ordered pair x and y that is on the line. Now we want to convert this or rewrite it into slope-intercept form. Now standard form is a useful form for a linear equation. I like to use it when I'm solving systems of equations. But slope-intercept is also a useful form, particularly since just by looking at the equation, we can find the slope of the line, the m, the coefficient of x, and this tells us how quickly the line is either rising or falling. And we also have b. This is the y-intercept. And so we know what's going on when x is equal to 0. Again, that's pretty useful information to have just by looking at this equation. But that's not what I meant when I said there's one feature of slope-intercept form that is great. We'll see that in the last few examples. So let's go ahead and convert this. So we have 2x minus 3y equal to negative 16. And when we write something in slope-intercept form, we're solving for y. We have y all by itself on one side, and we have a coefficient of 1. Again, when we have a variable and there's no coefficient in front of it, that means it has a coefficient of 1. So there's 1y, or y. Again, there's multiple avenues you can take. I'm going to go ahead and leave y on the left side of this equation. So we have 2x minus 3y. This means that 2x is added to negative 3y. So let's subtract 2x from both sides. We now have negative 3y equal to negative 2x minus 16. So nothing is added or subtracted to y, but we have a coefficient of negative 3. We have negative 3 times y. So let's convert this negative 3 to a coefficient of 1. And we're going to do that by dividing by negative 3. So negative 3 divided by negative 3, well, that's 1. So on the left, we now have 1y, or y, and that's equal to. And so what we do to one side, we have to do the other. So we're going to divide both the terms, all the terms on the other side, by negative 3 as well. So we now have negative 2 divided by negative 3. Well, that's a positive 2/3. So we have 2/3 x. And then negative 16 divided by negative 3. Well, that doesn't simplify down at all. We're going to end up with plus 16/3. So with this information, we know we have a slope of 2/3, which means it's going to rise 2 units. For every 3 units, the line goes to the right. And it's going to cross the y-axis somewhere between 5 and 6. So we can rewrite this as y equal to 2/3 x plus, well, 3 goes into 16 5 times, and then there's 1 left over. So that's 5 1/3. Let's go ahead and try another one. Here we have y plus 4 equal to negative times the quantity x minus 2. This equation is in point-slope form, so we have y minus y sub 1 equal to the slope times x minus x of 1. So that means we have the point 2, negative 4 on this line, and the slope is negative 1. But when you have an equation in point-slope form, every point will have a unique equation, because every point that's on that line is going to have a different x and y coordinate, so these x of 1 and y sub 1 values will be different. So we can have a lot of equations for this exact same line. Let's go ahead and convert this to slope-intercept form. So we have the equation y plus 4 equal to negative x minus 2. So when I convert this, my first step is to do this multiplication. So we have this negative. This means negative 1. So we're going to multiply negative 1 by the quantity x minus 2. We're going to distribute that negative 1. This gives us y plus 4 equal to negative 1x, our negative x, plus 2. And then from here, to get the y by itself on one side, we will undo this addition by 4 by subtracting 4. This results in y equal to negative x minus 2. Now let's look at this second equation. And we have y plus 9 equal to negative times the quantity x minus 7. And we're going to convert this into slope-intercept form using the same process. So let's first go and multiply this negative 1 to the quantity x minus 7. We end up with y plus 9 equal to negative x plus 7. And then to get that y by itself on one side, we're going to subtract 9 from both sides. And we end up with y equal to negative x minus 2. Well, these are the same equations. Y equal to negative x minus 2 when written as slope-intercept form. So when you look at these equations in point-slope form, well, they do have the same slope. For each of these, our slope is equal to negative 1. But for the original equation, well, this line was going through the point 2, negative 4. And for this second equation, it was going through the point 7, negative 9. So in this form, these equations look different, but they represent the same line. It's the same relation between x and y. In fact, all 6 of these equations here, if you rewrote these in slope-intercept form, they would all come out the same. So with a point-slope form, you have many ways of writing the equation, a different way for each ordered pair. But when you rewrite it in slope-intercept form, you end up with one equation. One equation that represents the relation between x and y, a point, an ordered pair that is on that line. So typically, if you do have an equation written in point-slope form, you'll want to convert it to slope-intercept form. Now let's convert these two equations, written in standard form, into slope-intercept form. With slope-intercept form, we have y equal to mx plus b. So we're going to get that y all by itself on one side, solve for y. And as before, I'll keep the y on the left and move everything else to the right. So the first step, let's get rid of this x term. We're going to subtract x from both sides. We now have negative 3y equal to negative x plus 6. So now we have negative 3 times y. To undo that multiplication, we're going to divide by negative 3. What we do to one side, we have to do to the other. And this leaves us with y equal to a positive 1/3 x minus 2. Now let's look at this second equation. Again, we want to get the y by itself. We have 3x added to 9y. So let's subtract 3x from both sides. we end up with negative 9y equal to negative 3x plus 18. Dividing by negative 9 in order to end up with 1y. We need to divide both sides by negative 9. This leaves us with y equal to 3/9 x minus 2. And then we can simplify 3/9. That's actually 1/3 x minus 2. And then once again, we have the same equation in slope-intercept form. So these two equations look different when they're written in standard form, but when we rewrite them into slope-intercept form, they end up being the same line. They're the same relation between x and y. With this first equation, we had x minus 3y equal to 6. If we multiplied everything in that equation by 3, we would end up with 3x minus 9y equal to 18. And that's the same equation for the second one. If we do the same thing, x minus 3y equal to 6, let's multiply that by negative 2. Then we're going to have negative 2x plus 6y equal to negative 12. So these equations are just multiples of the first equation shown, x minus 3y equal to 6. And you can tell if something is just a multiple by looking at the coefficients. Do they share a common factor? If we look at 3x minus 9y equal to 18, do these coefficients share a common factor? So in this case, we have a equal to 3, b equal to negative 9, and c equal to 18. So let's factor these and see if they have any common factors other than 1. Well, 3 is a prime number, so that's not going to factor any further. Well, 9, well, that's 3 times 3, and then also times that negative 1. 18, well, 18 is 3 times 6, so we can write this as 3 times 3 times 2, and that's 18. And so there is a common factor, and that common factor is 3. So that was that we multiplied the original equation by. So here we may have different equations, but they all represent the same line. And we can see that when we convert them into slope-intercept form. They're all going to convert into y equal to 1/3 x minus 2. So that is a great and useful feature for slope-intercept form. So we can call these equivalent equations. Much like 1/2 and 2/4 and 3/6, well, these are all equivalent fractions. And we use equivalent equations all the time. This is what we're creating when we subtract 3x from both sides, or we divide by negative 9. And we'll also use equivalent equations to solve systems of equations. So these multiple forms of the same line written in standard form are useful. And point-slope form is great as an entry or gateway into an equation for a line, even though you'll have a different equation for every point that is on the line. But like I said, you should probably convert that pretty quickly into another form like slope-intercept form. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So our goal here is to write these in slope-intercept form. So this is y equal to mx plus b. So we're going to get that y variable by itself on one side with a coefficient of 1. So for this first problem, the first step was to subtract 11x from both sides, removing it from the left side. We end up with negative 4y equal to negative 11x plus 32. And now to get rid of that coefficient of negative 4, we're going to divide both sides by negative 4, ending up with y equal to 11x over 4, or 11/4 x, minus 8. And then for the second problem, we have y minus 5 equal to 2/3 times the quantity x plus 6. So my first step in a problem like this is to use that distributive property and multiply 2/3 to the quantity x plus 6, resulting in 2/3 x plus 4. We already have the 1y, so we have y minus 5. To undo this subtraction of 5, we're going to add 5 to both sides, giving us y equal to 2/3 x plus 9. Drop any questions you have in the comments. Continue practicing writing linear equations in slope-intercept form, and I'll see you in the next video.